Hello everyone! Welcome to my workshop on integrating LoRaWAN gateways with the managed HiveMQ Cloud servers. I'm currently sending to you from the quarantine in Florida, so life could be worse. Before we get started, I would certainly like to take this moment and recognize that I'm very grateful for being in a position where I can do remote work like this, and I'm also very thankful to Lauren, Wienke, and the entire The Things network for setting this event up. All right, let's start by looking at a few slides about MQTT. Florian Raschbichler, and I'm the head of support at HiveMQ. As such, I make sure that our customers are successful. With my now close to 7 years of experience in the IoT space and specifically the MQTT protocol, I've had the privilege of accompanying over 150 companies on their journey from proof of concept to production. I also manage the HiveMQ community forum, where we support everyone with getting to know and using the HiveMQ open source products like the HiveMQ Community Edition or the HiveMQ MQTT client library. Whenever I can, I share my experience and knowledge in talks and workshops on conferences, by holding webinars, and by consistently contributing to the HiveMQ blog. Please feel free to check out the HiveMQ blog if you have any interest in the MQTT protocol. Looking forward to many more comments in the upcoming weeks. Not everybody is as familiar with the protocol as I am. Let's have a very quick MQTT refresher. MQTT is the most popular messaging protocol in the Internet of Things and is becoming increasingly relevant for Industry 4.0 use cases. Its design allows messaging with near instant data exchange at a massive scale. It follows the publish-subscribe architecture, which I will explain a little bit more in the next slide. One of the key characteristics of MQTT is that its implementation on the client side is lightweight, and all complexity is pushed to the MQTT broker implementation. With binary, data-agnostic payloads, it is well suited for machine-to-machine communication. Now, while this workshop is not designed to be all about MQTT, I think it makes sense to take a little bit of a closer look at the publish-subscribe architecture in more detail. MQTT differentiates between clients and the broker. Each client can be a publisher, a subscriber, or even both. All communication goes through the central component, the broker, and is based on so-called topic. For this graphic, we can assume that the topic is temperature. As you can see here, senders and receivers, in this case, the sensor is the sender and the laptop and the mobile device are the receivers of messages, are completely decoupled. They are only connected to the broker and do not know about each other. Now, when the sensor publishes the 21 degrees Celsius message to the broker knows that both the laptop and the phone have a subscription for the temperature topic, and it will publish the message to both of them. This shows that the communication is not only completely decoupled, but it follows an end-to-end pattern. You can have an arbitrary number of publishers and subscribers for every topic. I would like to add that topics in MQTT are fully dynamic, and proper MQTT broker solutions like HiveMQ can handle millions of topics at the same time. MQTT is useful whenever you want push communication so that your devices do not have to pull to get the most recent data. It's suited for reliable message communication, even if you have unstable networks to deal with or constrained devices with low bandwidth and or high latency. So now let's look into how MQTT actually comes into play with LoRa. So MQTT as an application layer protocol requires TCP/IP guarantees on the transport layer. This means that your LoRa devices themselves cannot speak MQTT, whereas your LoRaWAN gateway that is connected to the internet and has a TCP/IP connection can translate into MQTT, which is very common. Now, from the gateway over MQTT, you can forward your data to your MQTT broker, and any other client, which could, for example, be a powerful backend on your on-premise, can be connected to the broker as well and receive the data. And in your backend, you can have, for example, databases or processing technologies like Kafka that might be combined into a machine learning pipeline. All kinds of fun and powerful stuff. And MQTT with the broker in the middle is the perfect technology to connect your devices with your backend. Let's talk about deployment options you have for your MQTT broker. On the one hand, you could choose one of the available proprietary cloud vendors like AWS IoT or Azure IoT Hub. Another popular option is, of course, to self-host your solution. Self-hosted solutions are great for proof of concepts. Oftentimes, those proofs of concepts are done with open source solutions like HiveMQ Community Edition or Mosquito, which can lead to scalability and reliability issues for bigger use cases. Operating an MQTT broker cluster in production is not an easy task, and it is oftentimes the case that your use cases will be customer facing and the threshold for downtime are very slow. So you need a proper 24/7 operations team, which requires time and people and money. Now, those of you that saw my talk at the last Things conference know what all the great MQTT5 features are, and if you didn't, you can go watch it later. It is on YouTube on the Things Networks channel. Now, while Azure IoT Hub and AWS IoT and Google Cloud IoT come as a managed service, they do not come with MQTT5 support, and at this point it is doubtful if they will ever have it. So here comes HiveMQ Cloud to the rescue with combining 100% compatibility for all MQTT specifications and the comfort of a managed service in the cloud. HiveMQ Cloud is completely managed. It is built for production. It is agnostic to all clouds, comes with automatic scalability and reliability. We have enterprise-grade security and come at a predictable pricing with awesome observability for IoT devices. And very soon, integrations to the best-of-breed third-party services will be added. Now, if you look at the enterprise-grade security, we achieved that with not only TSL encryption for all of our communication, but we also have additional authentication, not only for the MQTT clients, but also for the access to the HiveMQ Control Center. Speaking of which, the HiveMQ Control Center is a unique tool that provides insights into all of your clients connected to the clusters and even for the sessions of the non-connected ones. at real time you can monitor the health of your cluster, and it comes with advanced additional analytic functionality. But enough with the talk. Let's get going and see how we can integrate HiveMQ Cloud. Let's go to cloud.hivemq.com. Now we click sign up now. And here you can create your account. I fortunately already have an account. So I log in. Entering our correct company and credit card credentials, we get the chance to start a free trial cluster. Now we need to set up a user for our control center. I'm going to call this one LoRa user. We need a secure password here, and we will create those credentials. HiveMQ will now build this cluster in the cloud on dedicated hardware. So this will take a minute or two. I will see you in a bit. Now that our cluster is started up, we begin our journey by adding credentials. Remember, we cannot connect any MQTT client without device authentication. So we will add a gateway client using password 1 here as our password. And we're also adding a backend client. More so, we're adding credentials for a backend client. We already have a control center credentials client. So very cool. Next thing we do is we will save the URL that our cluster can be reached under. And we will also save our control center link right here. Okay. Now, for starters, let's check out the control center. Using the credentials. And here we can see a running HiveMQ broker with nothing to do at this point in time, of course. Okay, now let us start doing stuff. And by doing stuff, I mean connecting MQTT clients. Unfortunately, I do not have an actual LoRa gateway that I can connect handy here. So we will circumvent that by using the MQTT CLI to simulate backend subscribers as well as our LoRa gateways. So start by connecting a backend subscriber on the topic LoRa test with quality of service 1. We use this as a persistent session, so we have a session expiry of 1200 seconds. This will mean that we have 2 hours. Our session will be stored at the broker. And we're connecting to our broker on port 8883. And we did not use their correct credentials, and this is why we're not authorized. We are using the backend credentials. And this time we received the acknowledgement for our subscription. We will disconnect this client again because we want to demonstrate persistent sessions with it. On top here, I have a second backend subscriber who subscribes to a wildcard topic plus LoRa. So it also, this should be plus test. So it will also cover the LoRa test topic that we're going to be using for publishing. And this one has the correct username and password. Okay. Now here on the bottom, I have 4 clients that simulate gateway clients. These clients all start publishing messages now to our broker using the gateway credentials. And as expected, the messages get delivered to our subscriber. Now, for this one round of publishes, I have marked one of the publishes as retained. This means that the 4 will be secured on this topic, persisted on this topic by the broker. Now, let's go back to our control center. And well, we can see that we have 2 subscriptions. We have 24 queued messages for our persistent subscriber, and we have that 1 retained message. Now, let's check out. We see here we have our connected backend, which has, as expected, our wildcard subscription. And we also have our disconnected persistent session from our backend, and this has the LoRa test subscription. And here we can see 24 messages are queued for the broker. So this simulates maybe a connection loss for your backend. The HiveMQ broker and the MQTT protocol will make sure that the messages you are interested in will be persisted on the broker. If we check for retained messages, then we indeed have 1 retained messages with content 4 as we suspected it and expected it. So this is all great news. Since we're here, we could also do trace recordings here for deeper analysis. So it would lead too far for this demonstration purposes. Now, if you're looking into our analytics tab, we see that there are no dropped messages that we see during all of our tests, which is what we expected. Okay, now let's see what happens when we reconnect our persistent backend. And as expected, we receive all the publishes that were queued for us, as well as the retained message on this LoRa test topic. Now, let's check back to our dashboard, and we can now see 2 connected clients, no more queued messages, same amount of subscriptions, and the retained message, of course, is still there. Now, if we subscribe to this topic with a new client, then we will receive the retained message. There we go. There is the 4. And now, what I was trying to demonstrate here is that all you really need is the credentials of the broker with the URL and the port, as well as a username password that you can set yourself. And as easy as that, you can connect to your managed cloud MQTT broker solution from anywhere, including, of course, your LoRaWAN gateways and all possible backend or other services that you want to connect as well. Here again, we see that the retained message remains on the broker. It's our quick HiveMQ Cloud demo workshop, and I hope you were able to follow what I was doing and you understood how you can leverage this service in the future to create a production-ready, enterprise-grade MQTT broker cluster with just a few clicks of a button. I want to take these last few moments that we have to take a quick look into the future with you together. What is in store for HiveMQ Cloud? Very soon, you will have the option to choose where you want your HiveMQ Cloud cluster to be hosted. This means you can not only select the region, but you can also choose the cloud provider of your choice. And here is a very quick look into some of the best-in-breed integrations we talked about earlier. We will provide integrations not only with your beloved cloud provider services that include device management, but also we will integrate with our technical partners ForgeRock and Confluent to integrate with their Kafka and authorization services respectively. Thank you very much for listening. Please get in touch with me if you have any questions about HiveMQ or MQTT. I am always happy to talk about either of these topics. And also, please go and check out cloud.hivemq.com for yourself. Now I will be taking questions in the YouTube chat. And once again, thank you for listening, and thank you to the Things Networks for organizing this awesome